All right, so we are in Unit 6. Unit 6 is the Introduction to Integration. So we're going to start with the fundamental theorem of calculus, which creates the connection between differentiation and integration. So just some facts about FTC. F is a continuous function on an interval containing a. Then we know that if we take the derivative of the integral, then we get back to the original. So again, the derivative of the integral gets us back to the original. If f is a continuous function on an interval containing a, then capital F of x is known as the antiderivative of the integral from a to x of f of t dt. And if f is continuous on an interval from a to b, and capital F is the antiderivative of lowercase f, then the integral from a to b of f of x dx is equal to f of b minus f of a. So let's look at some examples of determining values of g of x from a graph of f of t. So we have that g of x is equal to the integral from -1 to x of f of t dt. And what we want to do is work backwards in order to find our area. So g of -3 would look like the integral from -1 to -3 of f of t dt. But we know that we don't like our integrals to start on the right and work to the left. So really that's the same as negative the integral from -3 to -1 of f of t dt. And then what we're going to do is find the area between -3 and -1 on that graph. So we have a triangle of base 2, height 1. So you have 2 times 1, which is 2, times a half. So the area of that triangle is 1. And then because it's all below or that negative out in front, that would equal -1 times -1. Which would make the answer 1. Okay, and now we're going to look at -1. So we go from -1 to -1 of f of t dt, and this is an integral property, which we're going to talk about at the end of this slide. We know that any integral that starts and ends at the same upper and lower bound is always 0. So again, that's just kind of testing your knowledge of do you understand integration. Then we are going to look at the integral from -1 to 1 of f of t dt. So that is the space from here to there. So again, we have a triangle. This time our triangle has base 2, height 2, which is 4, times a half, which is 2. So the integral from -1 to 1 of f of t dt would equal 2. We're going to take that idea into account as we find the area of the next space, which is basically taking the area that we had here and adding it so that it goes all the way over to 3. So it's both of these regions. So you have two ways of thinking of it. You could say that it is equal to -1 to 3 of f of t dt. Or we can say that it is 2 plus the integral from 1 to 3 of f of t dt. So either way, we know that that first blue section is 2. We know that the area of a rectangle right here, so width 1 and height 2 would be 2 as well. And then the area of the last piece, so height 2, base 1 gives you 2. 2 times a half is 1. So everything is above, so we're adding or summing it together. And we would get that the integral from -1 to 3 is 5. Or what that means is g of 3 is at 5. So just down here, I have some important recalls. You want to recall how the direction of integration is important. We saw that in that first example of g of -3. And then the second part is that the starting location of the integrand matters. So this one started at -1 and not 0. So you need to also take that into account. Okay, using the points from the previous slide, let's graph the function g of x, and then let's talk about the answers to those questions. So let's graph g of x, and we'll graph it in red. So in order to graph g of x, we're just going to plot those points we found. So we said g of -3 was at 1. And then we said that g of -1 was at 0. And then we said that g of 1 was back up here at 2. And then we said that g of 3 was up there at 5. So we can see that the graph kind of goes down here, then comes back up, and continues going up till we get to there. So just smoothing that out. So it says, where is g of x increasing? Well, the graph would be increasing from -1 to +3. And I know this because the area under the curve is all positive. Where is g of x decreasing? The graph is decreasing from -3 to -1. And that is because the graph is below the curve, therefore it has a negative area. And then it says, where is g of x concave up? So the graph would be concave up from -2 to +1. And again, we can kind of see that right in here. And our reasoning for why it's concave up there is because the function f of t is increasing. So it is concave up because f of t is increasing. That would be my calculus-based justification. So g of x is concave up because f of t is increasing. And then where is g of x concave down? Well, the graph is going to be concave down from -3 to 2. And from 2 to 3. And again, that is because the graph of f of t is negative in its slope or decreasing. And then it just says, what is the relationship between f and g? And this is a super important question because understanding what their relationship is will give you a better understanding of the fundamental theorem of calculus. So basically, their relationship is that g prime of x is equal to f of x, or in this case, f of t. So g prime of x is equal to f of x. Holy technical difficulties. What? All right, so here's a calculus-based question on the same concept, but set up with a table instead of a graph. So it says, what is the value from 0 to 6 of f prime of x dx? So we're given that this is a twice differentiable function. So twice differentiable tells me that it's continuous. Continuous tells me that I can find the antiderivative. So we're going to use our antiderivative rule that from a to b of f prime of x dx, that it is equal to capital or f of b minus f of a. So in this case, this would be equal to f of 6 minus f of 0. So f of 6 is 2. F of 0 is negative 22. So 2 minus a minus 22 is 24. So the integral from 0 to 6 of f prime of x dx for this problem would be 24. Okay, and then the last thing is just looking at our definite integral rules. So you might want to print this page, take a screenshot, have this out with you whenever you are taking your test. Remember the 0 to 0 rule. So if you go from a to a, it's always 0. If you have a constant, you can bring that out in front. And if you're adding integrals of two different functions, you can think of them as being added separately. If instead of going from a to b, you want to go to b to a, we'll put that negative out in front. And you can add integrals together as long as the upper bound matches the lower bound. So let's just look over here at an example. We go from negative 2 to 0 of f of x plus 0 to 3 of f of x. So from negative 2 to 3, the area is all above, so our answer would be 7 units squared. Here, this is applying those properties algebraically. So we have the integral from negative 1 to 3 of 3 times f of x. So since f of x is negative 2, 3 times negative 2 would be negative 6, minus 2 times g, which is 5. So it would be negative 6 minus 10. So that's negative 16. And then here we have two g of x functions, and we want to go from negative 3 to 5. So this is a case where you match your bounds. So we would say that this is the same as adding negative 3 to 1 plus 1 to 5. So that's like adding 6 to 8, which is 14. Okay, that is all for FTC and definite integral rules. Hopefully this is a nice foundation for your AP exam. Thank you.